I will explain step by step how I solve this decision-making problem under training, which involve different types of crops and rainfall scenarios. The idea was to analyze which crops is more robust against climate variability. First, I start with the table that recorded the hard benefits of four crops: corn, peas, beans, and rice, evaluated according to the intensity of rainfall during drought, which was qualified rain and heavy rain, well rained, light rain, and that. This table provides a starting point to understand how favorite or favorite its crops was in each scenarios. For this specific example, I will explain the optimistic maximum criterion for gains, which involves selecting the highest value for each crop and then choosing the one that presents the maximum overall benefits, focusing on the best possible scenarios for each option. The process was as follows. First, data collection. I analyzed the table and understand the benefits associated with each crop on the different rainfall intensities. This step is fundamental because it forms the basic on which the criteria will be applied, as I need to know the possible outcome for each crop. Second, identification of maximum benefits. For corn, the maximum value is 96. For peas, the maximum value is 85. The beans maximum value is 97. And for grass, the maximum value is 82. 52. Sorry. This is because under the optimistic approach, it's assumed that the most favorite scenarios for each crop will be achieved, so only the best result is considered. 3. Selection to the crops with the greatest overall benefits. When the maximum values each crops were obtained, I compared these values and chose the crop that presented the greatest overall benefit. In this case, the beans has the maximum value of 97. This step is critical because the maxims criterion focus exclusively on the most favorite scenarios, which means opting for the alternative with the greatest potential gain, without considering risks or less favorite scenarios.
I detail how I approach this decision making problem under uncertainty using a cautious approach that involves various types of crops and different rainfall scenarios. The goal was to determine which crop offers the most security against climate variability. I start with a table showing the harvest benefits for focus crops, corn, peas, beans, and droughts. This table provides a basis for assessing on advantages or disadvantages each crop was in each situation. In this case, I use Wald's pessimist criterion, which focus on identifying the worst possible outcome for each crop and then selecting the one which the best of these worst results this minimizing risk. The procedure was as follows. One, information getting I examined the table for understand the benefits associated with each crop under different rainfalls intensities. This tips the crucial as it provides for foundation for applying the criterion, allowing me to know the possible outcomes for each crop. 2. Determination of minimum benefits. For corn, the minimum is 12, 11. For peas, the minimum is 45. For bean, the minimum is 19. For grass, the minimum is 46. This approach assumes that the most unfavorable scenario for each crop will be faced, so only the worst result is considered. 3. Choosing the crop with the best of the worst results after identifying the minimum values for each crop. Compare these values and select the crop that presents the best of these worst results. In this case, grass has the highest minimum values of 46. The steps is essential because Wallace criterion focus on minimizing risks, ensuring that the alternative with the less negative impact is chosen. By applying Wallace and pessimistic criterion, I conclude that the grass is the safest option as it offers the best performance in the worst processing scenarios, disproving grid protection against climate uncertainty.